one and all, now the students have arrived. We may proceed. We have honored guest students, University of Hawaii architecture grad students, under the tutelage of Dr. Jill Edelman. So thank you all for coming, and we will have latecomers who sign in right this. Well, Hawaii is the first state in the nation to declare 100% clean energy as a goal. And we're getting there. We're leading the nation in solar. But one of the quickest ways to achieve real energy efficiency is to design your building very, very efficiently. And if you do it with modeling, which is what if you do it with modeling, which you can shift your building priorities and your interior building priorities with a metaphorical link of the wrist, that is the real way to initially get yourself started towards really, really energy efficient buildings in the most efficient way possible. And that causes me to bring to the stage the mistress of ceremonies. That's not doctor, but Jessica Ho, who will be found somewhere. Here she is, Dr. Jessica Ho. Thank you. Take it away, Doctor.
Thanks for that introduction, Howard. I think I'll learn to be mistress of something. Thank you guys so much for coming. Some housekeeping items. If you're looking to get continuing education hours, you are in luck. This session counts for 1.5 credits, so it's going to be automatically added to your profile. Just be on the lookout for that. This is our course description for the day, along with our 4 learning objectives. I'm going to skim past all of that. Today's session is Introduction to Energy Modeling. It's part 1 of a 3-part series. Our second session is going to be on October 29th, the same location, and we're going to be going through a variety of different energy modeling tools, just so that you can get an understanding of what is out there and what might fit you the best. And then our third session is a hands-on energy modeling workshop. You'll be able to get a real feel for what it's like to spend time in an energy modeling tool. And the details of that are still TBD. So we'll get that over to you as soon as it is available. You're going to be hearing from a variety of different people today, myself included. My name is Jess. I work for a firm called IMEG. We have Eric Coldrup on the call with Coldrup Consulting, and then Ron Chatterjee over here with the State Energy Office. We all have experience with energy modeling, and so we're just really excited to share this content with you guys today. And then there's been an entire army, an entire slew of people behind the scenes that we have to give a huge mahalo to. Firstly, AIA Honolulu, along with all of the members of the Committee of the Environment. Thank you guys so much for your input and your help with this. And then another huge mahalo to Gail Suzuki-Jones, Howard Wigg, Thor Mendez, all at the State Energy Office, along with Karen Shishido with Hawaii Energy. They provided the good sushi in the back. So thank you so much for that. And last but not least, and to introduce our panelists, we have 3 amazing, gracious architects calling in from across the nation. Various time zones, like basically almost midnight. So huge mahalo to them for showing up and sharing their ike or their knowledge with us here today. We are beyond grateful. And yeah, I'm gonna pass it on to Nate to tell you guys a little bit more about himself, and then to Jessica, and then to Jack. So Nate, you are up.
All right. I hope you can hear me because your audio has been going in and out a bit. But I'll give an introduction. So I'm Nate Kipnis. I'm principal of Kipnis Architecture and Planning. We're based in Evanston, Illinois, and Boulder, Colorado. And we've been specializing in sustainable design for residential, kind of higher end, but we also do some affordable housing. And I was the past national co-chair of the 2030 commitment for a couple of years. I was a founding member of that committee back in '09. And I've been on a number of other national committees, and I'm happy to be here. Um, okay, great, thanks. So this is just kind of a slice of some of the work we've done. Um, our tagline is high design, low carbon. So I think it's very important for us to do, really great, super efficient buildings, but also still understand that we want them to be really well designed. Um, a couple of them here, the bottom left one, whoops. The bottom left one is a passive house that we just finished in Evanston. And that's what this example of the passive house energy modeling is going to show. And the one in the middle on the bottom, that's one in Boulder, Colorado, that every angle is based on the equinox, the solstice, sunrise, noon. The sun kind of whips around in that house, which is really kind of fun. You can go to the next slide. The next one is going to show energy modeling. We use a program called Sapphira. There's lots of other programs that you can use, and I'll talk about that when we're getting into the panel discussion. If you could advance that slide, that would be great. So the passive house, this one is interesting. When we do energy modeling, if you could go back one, just second slide, please. That one shows different iterations of that energy model. And we did one iteration with double glazed, one with triple glazed, and with different numbers of panels. And we're able to make decisions based on that, which is really great. We do our own energy modeling in-house. And so you can see those iterations. You can see the EUI in that third column of data. And the difference between all of them, we ended up going with this one in blue, 28 panels. And the last one just shows some pictures of that final, of the actual house. And in particular, there's a light shelf that we used in there. And that helps shade the house, but also bounces light up onto the ceiling. You see that in the middle of that bottom slide there. The fire you see is actually a linear with the air conditioning running in this very nice, very luxurious home. And also the picture on the stairs, you see, because of Passive House, we had a limit how many windows we used. And that is taking the light and bouncing it off of a perpendicular wall and then re-reflecting it into the space. So very careful on how we were doing daylighting. And that's the 3 slides.
Thanks, Nate. Hey, everyone. My name is Jessica Goswick. I'm an architect and the building performance lead for Architects Fora. We are a super small, 100% women-owned, fully remote architecture and community design firm based all over the US. And I am specifically based on the Central Coast of California. So I'm joining you all today from San Luis Obispo. And our portfolio is focused primarily on affordable housing in the San Francisco Bay Area, throughout California, and then all along the West Coast, so Washington, Oregon, and Colorado. Go to the next slide. This is just a slide about our firm. Oh yeah, there we go. So that's our firm. Our slogan is "Everybody deserves a place to call home." And on the next slide, I have an example of some of the sustainability work that we've been doing over the past 3 years. I've been leading the development of our sustainability action plan and guiding our firm towards these sustainability goals that we've set together. We created our first sustainability action plan in 2022, and energy modeling was super important to us to help us understand where we were starting from and establish the baselines of performance that our portfolio currently had in order to make more advanced design decisions later on and advance those goals further. I think by modeling our energy usage, we were able to also make our buildings more comfortable. We've found ways to make them less expensive over their lifetimes, which in affordable housing is really, really important to our clients. And some of them have like blossomed into even more by creating community hubs. So I have a project that just finished construction this year that we were able to engineer the photovoltaic system and battery system to provide backup for the community room so that it can run for 3 to 5 days after a power outage, which in the Bay Area is becoming more and more common due to wildfires. And so this was a way for us to make sure that the system was efficient and working as intended so that folks had a place to keep their medications cold or go in the case of extreme heat events and know that there was always going to be air conditioning and power there. So these are some examples of some of the softwares and programs that we like to use at our firm. The first one on the left, top left, is climate analysis, climate consultant, which provides climate analysis, not energy modeling, but I think this is a really great start if you haven't used it before, because it's a great way just to understand what strategies are going to be most efficient as a starting point. Below that is a parametric modeling software that we've had the opportunity to use through one of our consultants on a current project. And that's really exciting because it allows you to test thousands of options at once and find which one is going to be the most effective and get you towards your goals, or which combination of options can get you to those goals. I'll talk about that a little bit more probably today during the panel. And then on the right, the one on the bottom is another one that came from one of our consultants that we work super closely with. And then the one on the top is a conceptual energy model that we did using Revit Insight, which is kind of going through a transition right now, but still provides a solid like initial EUI if Revit is a software that you all are using. Then I'll pass it to Jack.
Awesome. Thank you. That's a big picture of me, it looks like on your screen. I'm just getting either over or into a cold. I'll pretend it's getting over, so excuse me if I sound a little stuffed up. I'm really excited to be here and share the stage, as they say, with Nate and Jessica. I run a small company called C-Scale that provides whole life carbon modeling software to architects across the United States, Canada, and beyond. The work on this really came out of work that I did when I was Director of Climate Strategy at EHCD, an architecture firm in San Francisco and Seattle, where I got to work on some really cool projects, including the YouTube Mass Timber headquarters and the renovation of the American Institute of Architects headquarters in Washington, DC. I'll be talking about something related to, but a little different than energy modeling that still falls under the, we'll say, general umbrella of performance modeling, which really is looking at the carbon emissions associated with construction and operation. And I think as this sort of, we'll say, lead in, I want to talk about why I think that it's important that architects care about embodied carbon. And it's really crucially that the power that we have as designers is something not to be taken lightly. So embodied carbon, right, is the word for the climate change causing emissions associated with material production and distribution. And if you go to the next slide, designers are in this really interesting place where with every stroke of a pen or like a line on a PDF that's made, mountains move somewhere in the world. The designs that our architects do, they summon materials from sometimes the far corners of the earth so that there's copper wire in the walls, there's concrete in the foundation, and there's steel sheeting on the roof or whatever that combination of materials is. And the small ways that architects design day in and day out really have these far-flung effects on the world around us and can be a major climate burden or a major climate solution. So the decisions, right, that architects make, I mean, literally, like, can move mountains, can contribute to the exploitation of land and resources globally. Or alternatively, the same choices by avoiding resource use or using regenerative materials can contribute to better solutions. So if you go to the next slide, The counterpoint to that really is that the same decisions made differently can do things like regenerate landscapes. And I see the work that we do, which is really focused on embodied carbon. And to measure embodied carbon, there's a technique called life cycle assessment. If you go to the next slide, as being a really essential way that as designers, you can tell the difference and try to understand the impacts of your decisions. So this sort of like life cycle assessment includes some treatment of energy related emissions, but we'll say is complementary and a way to understand, the energy use in a building and the embodied emissions from the construction materials all together is a great way to build a holistic picture of the building's impacts as you're modeling through the design process to, bring about better buildings for a better world.
Awesome. Can we give a round of applause for our panel? Thank you guys so much for being with us again. We're gonna get into the content and then get to talk to our panelists in a little bit. But first we'll go over some of the basics of energy modeling. Why do it? What is it? What results do you get from an energy model? And then we'll talk about how it's used over the project lifecycle, along with some local energy incentives. And touch a little bit on the tools that we use, wrap it up with some more panel questions and audience questions. So feel free to start brainstorming some of those. Okay, getting into why do building energy modeling. This is such an important question to ask at the beginning of any project. Frequently, energy modeling comes up in terms of energy code compliance. You could either go down the prescriptive pathway or the performance pathway. If you choose performance, you need an energy model. Energy modeling also comes up when you are designing a high performance or a green building certification, such as LEED, WELL, living building, all of that stuff. So these examples of high performing buildings on the screen likely used an energy model within their design. Another common answer for energy modeling is research. If there's an innovative technology out there and we want to see what it does to a building, that's a way to use energy modeling. And then, of course, policy development when it comes to code updates and understanding the effects of that. I'm going to ask for some audience participation. So can any of you guys give me another reason that isn't on this common answers list for using an energy model? Yes.
Long-term operational cost reduction.
I love that. Yes, an energy model can certainly be used to see future cost decisions. So that's such a good answer. Anybody else?
Looking onto yours, basically lower energy use.
Definitely. Optimization, setting priorities for sure.
You're also protecting your building against obsolescence of old outdated equipment.
I love that. Again, the forward thinking, the future thinking, the long-term thinking. Our buildings are around for quite some time. And so that's so necessary when it comes to, first getting started designing a building. Definitely related to everything that was brought up, but some more interesting answers is to help with the design process, help answer design questions, make it a little bit easier and have some data behind some of those decisions. Another one would be to identify some priorities. What's gonna make the most sense from a cost perspective, in terms of first cost versus operational costs, all of that sort of stuff. And then sometimes energy models can help us challenge rules of thumb and ways of thinking. So all things to consider when understanding what an energy model can provide for you. I'm gonna guide us through some rhetorical questions that kind of gets your mind thinking of questions you might want to answer with an energy model. So you might be wondering what the impact of your glazing area, how that affects your operational energy. That's certainly something you can do with an energy model. Another one might be which envelope components contribute the most to peak cooling. And then you can from there try to optimize that. which energy end uses contribute the most to energy use intensity or your EUI? Is it your cooling? Is it your interior lighting? That's something an energy model can help you with. You might be wondering what the impact of massing on building performance is. And you can look at that from a consumption perspective. You can also look at it from a cost perspective and of course, a carbon emissions perspective. At the start of a project, you might be coming up with different conceptual designs and wondering, is it going to meet the 2030 challenge that AIA has set? Can it eventually achieve net zero carbon emissions? And from the start, it's gonna influence what changes can be made from there. You might have a list of different efficiency measures and you might just want to see which one reduces the most energy or which ones can get you to your energy target. So again, prioritization and hoping you make decisions. This is another list of even more whys behind energy modeling. This doesn't even cover the expanse of what's out there. So just keep an open mind when it comes to energy modeling and understand that it's a tool in your toolbox for all architects. And that leads us to our first panelist insight. So we're going to turn it back to Nate, Jessica, and Jack and ask, why should architects use energy modeling in your practice? Why do you guys use energy modeling in your practice? We'd love to hear your experiences. So I'm going to pass it first to Nate. Nate, can you hear me okay?
Yeah, boy, I am having a really hard time hearing you guys. It's cutting in and out a lot, but I'll just pretend that you can hear me. So why should architects use energy modeling in their practice? Well, you can't improve something if you don't know where you're at. So, you need to baseline your work and then improve. And I always tell people when I'm asking them to join the 2030 commitment, for example, because right now you're supposed to be 90% better than baseline, which is the energy use of a home or a building from 2003. Don't worry about that. It is not about trying to hit that target. If you're just starting, there is no way on earth you're going to hit that. It's about making progress. It's about understanding the impact of your decisions and then adding to it every year or every project. So don't get bent out of shape about that, hitting a 90% reduction or even just, even half of that. Just try and figure it out. Try and do some energy modeling, see where you're at, and then make improvement over and over again.
I love that answer, Nate, for sure. Understanding where a good starting point is and then getting to see those savings manifest. That's an awesome qualitative thing to do when you design. I also think it's important that you brought up that it's not always just about the target. Good design is going to lead to good energy usage and good performance of the building. So another important thing to keep in mind. I'm going to pass it to Jessica. Why should architects use energy modeling?
Yeah, I'll jump off on that, talking about just making better decisions in general. I think as architects, we're all making a lot of decisions. We have a lot of decisions to make when we're designing. You guys know that you do it every day. And energy models are just tools for helping us make those better decisions. I think that in our work, it's really helped us communicate to clients why we're making the decisions that we're making and how we can better meet their goals. So sometimes the goal isn't net zero or meet the AIA 2030 commitment, like Nate was saying. Sometimes the goal is actually like, we want to be able to, like I was saying earlier, power this part of the building with only solar. And so we have to actually understand how much energy that part or that building is using to understand how much solar we need and make sure that that cost is going to be efficient and effective for our client. Alternatively, like the goal might be that they want to pay their electricity bill using some funding that they have. And so they have a limited amount of funding and we're trying to match the bill with the funding that they are able to have. And so being able to actually see what that is going to be and predict that before the building is built helps us make better decisions and create better buildings for our clients and the people that live in them.
Love it. Jack?
Sure. To pick up on a point that was on an earlier slide, I'll talk about one sort of like I think one of the most exciting aspects of performance modeling, which is that it has the ability to challenge commonly held notions about what good design might be, or what even energy efficient design might be. I think to Jessica's point, architects make a lot of decisions every day and need to make them quickly. And sometimes the need to make decisions quickly to move a project forward can lead to sort of like ruts in thinking, repeated actions. But every project, is a snowflake, is unique, like requires its own sort of like special approaches. And modeling is a way to capture the complexity of a project and abstract representation of that project, the model, right? That allows you to understand its particularities. Why you might need, to Nate's example, a solar, a light shelf on one side of the building. Why you might need more glazing or shading somewhere else in the building. These are questions that just rules of thumb and best practices might not make obvious to you, but that modeling can help you see. I think that's really important. The other thing I'll say is that, architects should participate in energy modeling, but really the thing that's most important is that projects, the energy modeling happens on projects, which means that sometimes the architect does it, but sometimes the architect actually is just to know enough about energy modeling to ask good questions to the consultant that's doing it. I think it can be intimidating for sure to take on this whole new discipline of energy modeling, but the trick really, like Jessica and Nate said, is just to get started somewhere and then build skills internally while also leveraging, the expertise across the industry, right? To make sure that, again, you're just moving the project objectives forward with these modeling practices.
Awesome. Thank you guys so much for your answers. I think we're going to move to our next section, and I'll pass it to Eric.
Thank you, Jess, and great to be here, y'all. I'm an energy modeler based in California, and so my job here is to kind of step back. We heard a little bit about why we might want to use energy modeling, some of the things that it's good for. I want to step back and talk a little bit about what is building energy modeling, because I think that if we have a little bit of that understanding, then we can perhaps use modeling more effectively. So let's just take a quick tour here. So when you are what are you doing when you create a model and run a simulation? Some of you have done this, probably a lot of you haven't. So you're identifying a building design, right? So if it's a new construction project, maybe it's even pre-design, you are thinking up a building design. Maybe it's just building massing at that point. Obviously, during later stages of design, there are plans that you're working off of. Or if it's an existing building, there's an existing building there and you gather information about that existing building. Whatever it is, you're going to describe the characteristics as inputs. So most software has a graphical interface where you can enter information, and then it's stored in some sort of data format, which might vary from software to software, but basically it's describing all the characteristics of the building in an electronic file. We then select a weather data file. So that's essentially identifying the location. So there are a bunch of weather data files for the state of Hawaii. Most commonly, we choose what we call TMY data, or typical meteorological year, for kind of a representative analysis. But more and more, we're using future weather files, which are developed from one of a number of different methods, which will help us to understand how that building might perform under future climate scenarios. And also some people are working on extreme weather files, which will try to represent extreme weather events, which can also help us, especially if we're trying to, evaluate the impact, how comfort might be maintained, for example, under extreme weather. So we take those two inputs and we run the simulation software. This is doing like an hourly calculation for a full year. It's calculating energy use for things like lighting and plug loads. It's calculating the heating and cooling loads for each space, and then doing a calculation on the HVAC system and the energy used by the HVAC system. And then hopefully we're extracting useful results. That's the whole point. So we can get output data and perhaps repeat, because most of these analyses are part of an iterative design process where we explore an idea, we learn something, and then we move on to the next question. So that's kind of what you're doing. And then a little bit about the information included in an energy model, because it may be not obvious. It's different from the way we describe, say, the building geometry on the plan. So the geometry is represented space by space in an energy model. So if you looked at the basic data file of an energy model, you'd see a list of spaces and each of their characteristics and their exterior surfaces, interior surfaces, fenestration. And then the building is a collection of spaces. We can then also define shading objects like overhangs or even adjacent buildings. We'll define the thermal properties of the opaque components, the conductivity, the thickness, the density. They're typically defaults for all of these things in this software, but this is the kind of information that's going in there. And then the thermal and optical properties of the windows and skylights. And that would be, right, your U factor, sort of heat gain coefficient, visible light transmittance at the sort of simple level. So that's the kind of information about the geometry and the envelope constructions. And then we define internal heat gain. So we need to tell the software how much power there is for lighting equipment, meaning like things like office equipment or other indoor energy consuming equipment, because all of that energy consumed by the lights and the computers and all that ends up as heat in the space. And then the occupants, because each of us is basically a 100-watt light bulb in terms of the energy that we're putting out, heating up the space. So the program needs to know that. We may define infiltration and natural ventilation. That's another source of loads for the space. Warm, moist air infiltrating into the room. And then finally, there's the HVAC description. So there's quite a bit of information about the thermal zoning, outdoor air ventilation rates. In Hawaii, that has a big impact on energy use. You're bringing in that warm, humid air, needs to be cooled and dehumidified. So the volume of that has a big impact on your energy use, and characteristics of all of the HVAC components. If you look at one of these early design tools, they'll typically simplify this for you, right? And they'll let you choose an HVAC system type, for example, and it will have a whole set of default inputs for a representative system of that type. Usually we're interested in energy costs, right? So then we need to define the utility rates within the model. This is especially important in places that have demand charges or time of use electric rates, because then you could represent the impact of design strategies that might shift the energy use from a expensive time of day to a less expensive time of day. So even if that strategy doesn't necessarily save energy, it might save you significantly on energy costs. And this is one of this is a good use for energy modeling to do that sort of comparison. And then finally, on energy models, there are variations in the boundaries of an energy model. It's not all just whole building energy modeling. We could get a lot of useful information from just, say, creating a model of a single room, especially early in design. But of course, we also model whole buildings. We may also add information about exterior uses, like exterior lighting. If you do a LEED calculation, for example, you have to include all these exterior uses that are on the building meter as well. You can put, in many programs, you could put PV systems in there so that you're modeling the impact of renewable energy. And clicking, okay. You can also get, you can have more than one building in an energy model. So you can model, for example, separate buildings as separate models, but they could also be in the same model. And finally, shading from adjacent buildings. So in an urban context, right, this would be important to represent. So that kind of gives you the idea of the scope of the kind of information that goes into energy models. And then really quickly, like what happens when the simulation runs. So each of these programs, there are a couple different simulation engines, but each of them has a zone model. So this is a model that calculates heating and cooling loads. So it takes these internal heat gain information, the building envelope heat transfer infiltration into the zone model. It calculates hourly loads. Then there's an HVAC model, which calculates for the HVAC system how much energy is consumed to deal with those loads. From the zone model, you get the lighting and plug loads energy. From the HVAC model, you'll get the energy use of all the various HVAC components. That gets added up to total energy consumption and potentially carbon emissions due to energy. All right, so we're all experts now on what's going on inside the energy model. I just wanted to also give a shout out to a couple other types of building performance analysis. So these are cousins to energy modeling. There's lighting, daylighting, glare modeling, airflow and natural ventilation. So this is something that some energy models can also calculate, airflow between rooms through openings based on, say, wind pressure or temperature differences. Of course, solar and shading analysis useful during early design, and then envelope thermal performance. So that might be like finite difference analysis to evaluate the detailed thermal performance of, say, thermal bridging in your construction. And as Jack mentioned, more and more we care about embodied carbon. So that's another type of building performance analysis that complements the building energy modeling. All right, and then my second job is to just do a quick tour of the results that you get from these energy models. Here we are at this extracting useful results phase, right? Of course, we get the whole building energy and demand. That's something we're all familiar with. We can get it annual, monthly, and also time step results. So this can be useful to get hourly electricity, for example, because in the context of carbon emissions, so operational carbon, in many places, the carbon intensity of the grid varies by time of day. So we could use these hourly results to get a more accurate estimate of operational carbon. We can also look inside and look at end-use energy consumption, as Jess mentioned earlier. Lighting, equipment, fans, various HVAC pieces of equipment, even domestic water heating, which is included in energy models. And then you can get those results to help you identify those opportunities, as Jess mentioned earlier. You can also get system and zone loads. So this is maybe more the concern of the mechanical engineer. But, as architects, we're also concerned about the impact of our design decisions on especially peak loads, right? Because that affects the sizing of HVAC and potential for downsizing, saving money on the HVAC system. The zone loads there, you could see the loads in each room, so you can check and see, well, which of these rooms has the highest load, and you might be able to then sort of target your efforts on those areas of the building that have especially high load densities. And then there's the system and zone conditions. So you could even see hourly space temperatures simulated. If you're doing an air-conditioned building, this is not necessarily that interesting, right? Because the temperatures would probably be following your thermostat set point schedules. But if you're doing a natural ventilated building, or say a hybrid natural ventilation, mechanical cooling, then you can see with different design strategies, different shading, different window, different installation strategies, how does that affect the hourly indoor temperature? And how many hours a year are you perhaps going to exceed comfort levels? And are there things that you can do to help mitigate those comfort problems? So that can be a really interesting analysis too. So ultimately, you're getting information to answer your questions. And depending on what your question is, it could be just EUI, or it could be any number of other things like peak heating and cooling loads. All right, so that's your quick tour, the basic primer. Now we're going to ask back our panelists to touch on this question. So we just talked about results from energy models, right? So like in what ways has energy modeling results influenced a design decision that you would not have made otherwise? Maybe we can start right to left. Jack, is this a question you'd like to take on?
Yeah, sure thing. Thank you, Eric. I'm going to even take a half a step back from the question. For really the most successful projects that I've been on where energy modeling is used, it's never, we'll say, an add-on just for one decision, but it becomes an integral part of the project delivery process. We've all sort of like read about different ways that project teams come together, but when I was at EHTD and working on projects where energy modeling was really at the heart of it, there was a real sort of ethic of sharing the design space with the engineers. This might sound radical, at some firms, but really it means that the structural consultants, the mechanical engineers, the energy modelers aren't just coming in afterwards to clean up the mess that we make with our nice shapes, but are part of the design process, right? So sometimes, like some examples, for instance, energy modeling on the AIA headquarters informed the shading strategy of a building that is not oriented particularly well toward the sun, and led to this really nice design move that I think we'll all be very excited to see once it's built, of a sort of sweeping solar shade that reduces glare and solar heat gain through those windows at the most important times of the day. And I think that's one sort of very particular example. But really, the thing I think I'll say again here as my closing comment is that energy modeling is most effective when energy modelers are given design input and not just like the ability to run results on a fully baked design that somebody else did.
Great. Yeah, it's a great framework for integrated design in that everybody kind of can see the impact of their decisions, the architect's decisions, the mechanical engineer's decisions, the electrical engineer's decisions, and pull it all together. Jessica, how about you?
Yeah, I totally agree with that. I think one of the hurdles we had was understanding how to best incorporate everyone all together and not just bring it in at the end, or in piecemeal, which is what Title 24, our California Energy Code, typically has us do, like in piecemeal, not the whole building, only some systems. So definitely recommend a more comprehensive approach when you can. I would say in terms of design decisions, this one's pretty recent, so it's top of mind for me, but I'm working on a project right now that's trying to get to net zero energy and achieve LEED net zero, or LEED zero in the coming years. And it's an affordable housing project, so it's on a super tight budget. And as we were designing, kind of to Jack's point about working with best practices and rules of thumb, we were like, well, this is going to go net zero, which means it needs to be as efficient as possible. And so we probably need exterior insulation, and that definitely should be in there. And like a few other things that we think of as being like energy efficient design, that should just be in there for sure. And then as we were running the energy model, and this was the parametric model that I showed earlier, so all the like loopy loops that generates thousands and thousands of options, one of our toggles was on, do we need exterior insulation or not, and how much exterior insulation would we need? And we found that we could actually remove all of the exterior insulation and just add ERVs to our mechanical system, which was going to end up being more cost effective because of the surface area of the exterior insulation. And so this was something that we probably would have never decided just by guessing, but the energy model was able to tell us, like, we're going to get to the same EUI, we're going to have the same kind of energy usage if we do this, and it's going to be cheaper for us to construct. And we are lucky to have our contractor on board early, so they're able to help us kind of verify that information as well. And we're moving forward. So now no exterior insulation on this project.
That's great. Yeah, I mean, sometimes we think of energy measures as adding costs to a project, but if we use the analysis effectively, we might even be able to reduce construction costs by eliminating the things that aren't that important and putting the money elsewhere. Nate?
Yeah. All right.
Thoughts here?
Yeah. So I have a very specific thing. So when we started doing energy modeling, I did not realize how impactful looking at the solar heat gain of glazing was by orientation. Super inexpensive to specify that, in the $20 a window range or something like that, and has a very noticeable impact. So that's what energy modeling, that's a really good example of something that energy modeling showed that I would have never figured out before. I also want to point out that energy modeling, depending on the program, can be very easy. It can be just like hitting a series of radio buttons, or you can dive deeper. So don't be, dissuaded by, some what looks like apparent complexity in it. It's actually fairly easy, and especially once you get through that first project and you understand it, the learning curve goes very quick. So keep that in mind.
Great. Thanks, Nate. So we'll probably, come back to discussions like this at the end when we have more Q&A. But now I think we want to invite Ron up to talk about our next topic.
Thanks, Eric. Appreciate it. So I'm Ron. I am with the State Energy Office, but in my previous life, I used to do energy modeling consulting services most of the time. So I'm just going to talk a little bit about how energy modeling is used over the project lifecycle and all the many ways it can be used over the project lifecycle. So I'm just going to step through all of these transitions and kind of work backwards here, because a lot of us have probably heard of energy modeling in that bottom box there in that context, for code compliance, to comply with code, and we can actually get the thing built for green certification, to get your LEED certification and your LEED plaque on your building. Also for utility incentives, we have someone from Hawai Energy here. We're going to talk about that in a brief bit, but if you want that utility payout for your building, you might have done an energy model for that. Those are some of the most common ways that modeling comes into the construction practice, right? But if you kind of notice this, the way the slide is, like, it's showing you the different design stages, right? And all of these three kinds of models really come in quite late into construction. Code compliance model, you're probably submitting that, close to % DD-ish, and you might do a few iterations after that. You're doing a LEED model that's based on constructed documents. You're essentially all the way there. Same with utility incentives, right? By the time you're that far into construction, most of the decisions are already made. These models are essentially just showing the decisions have been made and here's what it's going to perform like. But like we've been saying throughout this presentation, energy models are a way to answer different questions, right? So if you do models in earlier stages of your construction project, there are different types of models that you can rely on, and they can answer different kind of questions. So just as a few examples, when you're in pre-design, if you just have a simple box model, you can answer several questions that could have lots of implications in your overall building at that stage. Maybe it's a question of what kind of structural system you're going to use. What kind of carbon content might that have? Going with a typical steel structure, or perhaps you do something with mass timber. Those decisions are made really early on. And a simplified model, if you were to run that at that time, could give you some answers to those questions that could help you make those decisions. Same way you can move a little bit further down. Something I used to do a lot in Seattle at my last job was I worked on high-rise residential developments. And the developers I worked for, they really liked very tall glass boxes. They wanted the most view that you could have of the Puget Sound, which is a great view, lots of very pretty sunsets. But it was getting harder and harder to do that as the code progressed in Seattle further. So we had one developer in particular who we've been working with for quite some time. They were used to the previous code cycle that did not cap window ratio as aggressively as the code cycle later on did. And so to help them get to that goal, essentially starting with SD and all the way till about building permit and DD, we would do iterative spreadsheet models just to see whether they are compliant with their envelope requirements, trying to maximize the window area that they needed, as was their direction, but also making sure that they're meeting the thermal requirements set by the city code. So that's not quite a full building model, but it's a model at a different stage that can help you optimize your building for what you're trying to achieve. There are a few more, ways that building energy model is done in different types. The stuff in the red over there is leaning towards compliance. So those are compliance models that you're doing later on when most of all the decisions have been made, and you're essentially just figuring out what the overall impact of your design is going to be. And you send that over to your permitting office to get your building permit, or you send it over to LEED or ILFI to get your certification from them. Or to your utilities to get your utility incentive. And all the stuff over here to the left is stuff that you could do earlier on to help you make some of those iterative decisions on your building. I'm really quickly going to talk a little bit about how code compliance models work. A lot of you might already be familiar with this, but what you essentially have to do, because this is something that's done much later, you have most of your proposed design complete for your building, right? So you take your modeling software and you build it out to how you have specified your building to be, or as close as you can get that to be. And then what you do is you create a baseline model or a standard reference design model. And that is essentially taking most of what you're building that you are actually designing to be. So you'll notice that the geometry is mostly the same, but it is designed to be meeting the minimum prescriptive requirements of code. Or if it's a green certification building, minimum prescriptive requirements of that certification. So you'll notice like between the two of these, one thing that's noticeable for sure is the size of the windows, right? So your baseline is always going to be capped at what the prescriptive cap is for window area. But you can go further than that with your proposed model as long as you still meet the requirement ultimately, which is being 15% better for energy costs than that standard reference design. So this is what you would do for one of those compliance models. Just talking a little bit about why you would do code compliance modeling, right? Usually you do a code compliance model because you're not meeting one or more prescriptive requirements for code. So perhaps, the developer I work with in Seattle, they really wanted their window area to be maximized, right? That went beyond what code lets you do prescriptively. So it might be that, or it could be you need to, reduce your roof insulation a little bit. Perhaps you have a very nice roof deck up there for event space or something, and you can't have as much insulation. That's something. Maybe it's roof reflectance, window area, that's a big one. SHGC numbers, that could be another one. U factors, wall insulation. Perhaps, I know Jessica just talked about exterior insulation as something that she considered for one of her buildings. That comes up often. Exterior insulation can be quite expensive. And so if you're not trying to do that, do it a different way. These are all the things you can do. Lastly, to round out my slides, I'm just going to briefly give a little shout out to the ASHRAE IBIPSA Standard Tool 9. So a lot of us have been doing modeling for a while. We've kind of developed our own process for doing energy modeling. ASHRAE and IBIPSA. IBIPSA is the organization that most energy modelers are a part of. They kind of came together a little bit back and came up with their own dedicated standard for modeling. I'm just going to go through these really quickly, but it gives you an idea of what they suggest a modeling cycle should look like. There are several stages. They kind of lay out what times of different construction stages these should come under. And it's just something to look over if you're trying to get into energy modeling right now and you don't know where to start. There is a standard out there that you could rely on to get started on this. I think that's the end of my slides. I'm going to hand it over to Z real quick to give us a brief intro on the utility incentives that you can get here in the
Hi, everyone. My name is Ziriella. I work for Hawaii Energy, and I'm an energy engineer. They don't let me talk in public very often, but I'm excited to be here today. I'm really excited to see you all here today. Building energy modeling is not something I have direct experience with, but I think it's a huge untapped potential in Hawaii. So as an engineer at Hawaii Energy, I'm really excited to grow our program to give more incentives for energy efficiency that comes from energy modeling in new construction and major renovations of commercial buildings. So I'll start over on the systems approach first. So this is our like backup method, and it's what unfortunately we've been using most often for new construction and major renovation. Basically, if someone approaches us at any stage, or if they don't want to do an energy model, we can, as a backup rebate opportunity, if they're doing energy efficiency, we can do a systems approach where we look system by system through the lighting, HVAC, water heating, if they have Energy Star appliances, and we just give a prescriptive rebate for each of those systems. So for our program, basically any of our prescriptive rebates, they start as soon as you're 10% or more efficient than whatever the federal minimum is for energy code baseline. And for this systems approach for the whole building, we cap it off at $150 or $150,000 per project. So that's the backup method. But the new exciting method is the energy model approach. And we've done a few of these. The basics of it is if you come to us with a building that's early in design, preferably like in conceptual development, and the plan is to do an energy model, we want to pay for most of it. So we give, where we're at now, we want to pay for 75% of that energy model process to create either a code compliance model or, yeah, basically come to me with what you're doing and I will help work with that. But after the project is done and you have that full model that shows the baseline design, the proposed design, if it's actually built as it was proposed, we will pay 18 cents per kilowatt hour saved above the code standard. And that doesn't sound like a lot, but we cap it at 200,000 and projects have reached 200,000. So especially if for projects that are multifamily affordable housing, that's a main target of ours. We give bonuses for that. We remove the cap, first of all, so these can get very large rebates. And we give 15% basically above what we would normally give in rebates. Yeah, if you have any questions on that, I would love to talk to you. And if this is something that you haven't heard of before, let your boss know. Reach out to me. I'll have a few cards that you can come and get, or I can leave them somewhere. Yeah, we want to talk to you.
Thanks, Eve. We wanted to make sure that Hawai Energy kind of mentioned a little bit of this because it's definitely something that you can leverage for your projects. 200K. All right, with that, we're gonna move on to our next panelist insight question. Is where should we start when it comes to incorporating energy modeling? And I'm gonna ask Jessica to kick us off on this one.
Yeah, this is a good question. But this is something I've approached now at multiple firms that haven't done energy modeling and we're looking to start. And I think there's a couple ways you can approach it as a firm, or you can do them all together. One thing that's worked really well in some of my experience is working on a pilot project or a couple pilot projects at a time. So even if maybe your whole firm isn't on board, but you or your project team is interested and maybe you get your client on board, or maybe you are just interested in learning a software and testing it out. I found that that's like a really great way to demonstrate like, oh, this was pretty easy and pretty fast. And here's the outcome that I got. Here's some decisions that I made. And you learn a lot in the process of that just pilot project. So you don't have to wait for the entire firm to get behind whatever you're trying to do, to establish standards and determine this and that. It's good to do that too, but you can start with one project and kind of show how it could work for the firm and demonstrate the proof of concept. Another way that you can start is by starting with a very, very, very simple box model. It seems, I think sometimes as architects, we can think like, well, the more information I have, the better. So if I take this model that I've developed for CDs or that I developed for my building permit and it's pretty much done, and I just want to test the waters of energy modeling and throw it into Revit Insight or Sapphire or something and understand how it works. It's probably not going to give you very good results, especially if you're doing it yourself. So another way you can start is by using a super simple box model. So like when you're in the beginning of a test fit stage, a feasibility stage, working on concept design, and you have basically just like a little box with windows, that's, I think, the easiest way to start energy modeling, because you can put that right into Sapphire or into Insight or into any of these other programs that are out there. and it will give you a usable solution or a usable number that you can like make a couple tweaks on your building and see how that affects the outcome. So if I rotate it 90 degrees, how does that affect the outcome? If I change the window wall ratio to 30%, how does that affect the outcome? And that can be a little bit more manageable than working with a lot of components at one time.
Thank you, Jess. Yeah, I totally agree with what you're saying there. Pilot projects is something that we use at the state energy office as well when we're trying to develop concepts for policies. For example, we're looking into some virtual power plant based policy initiatives for energy codes in the future that we're currently running some pilots for. And the same goes for box models too. Totally agree that even with limited information, if you start a model, you can get quite a lot of answers to questions out there. I'll put it over to Jack. What do you think?
Well, after hearing Z's presentation, the first thing I would do is go after that incentive. That's an amazing program. Wow. What a great incentive to reduce, more kilowatt hours of demand if you get paid, whatever it was, 85 cents per, 16 cents per, I'm going to get the number wrong. But amazing that exists, honestly. Having worked on projects in a number of states, different versions of these programs exist. And this sounds like the strongest one that I've heard about recently. And it seems like a great way to do the sort of thing that Jessica's suggesting, to try it on a project. The other thing I'll say is that with all of this, get started somewhere, and you're going to be wrong, and it's not going to be quite right. But just like ask questions and stay curious. I mean, really, so many of these things seem like highly technical engineering exercises, and in a sense they are, but so is all of building design, and really trying to bring a design perspective to the way we ask these questions and maintain our curiosity. This is a nice thing sometimes about hiring talented consultants for some energy models, is you can really have a context in which you can build your expertise through conversations with others, and I think that can be important. Simultaneously, as you're doing your first project, just engage in other kind of communities of practice. Ron mentioned ABIPSA is a great resource. COAT is a great resource. Unmet Hours is maybe a little dorky, but there's like online forums that are really helpful for energy modeling. But the thing is that some of this knowledge lives in software, and most of it lives between people. So really trying to build relationships in the design community to support you in your journey is going to be really important in sort of making sure that, you're contributing and learning from the knowledge base that just lives in the design community.
Thank you, Jack. Yeah, and thanks for shouting out IBIPSA again there. Something that this little group that's putting this webinar series together is trying to do actually at the end of this, we are hoping to get in touch with IBIPSA headquarters to see if there might be enough interest locally here to launch an IBIPSA Honolulu chapter. So that's in the works, and hoping that we can get that to happen. I helped launch the IBIPSA Seattle chapter. We'll relaunch it a couple of years back, and IBIPSA is very helpful and wanting to make this happen all over the nation. So stay tuned, and hopefully we can make that happen. Lastly, I'll send it over to Nate for your insight.
I'm going to guess that I'm up. I can barely hear you guys, but I would say what you should do to start energy modeling is to understand what the baselines are for your building type. So, and then you have to set a goal for that. So again, the current goal is 90% better than baseline, but probably don't bother doing that. Maybe you set a 40% goal or a 50% goal. And the other thing I would say, you want to do it early and often. You do not want to reverse engineer this at the end of a project. Do not do that. And I think it's really a good idea to have the whole office understand what you're doing. So make it part of the office culture, and don't just have some genius in the corner doing this. That doesn't help anyone. You want to get everyone involved with it. I also think I put some things in the comments about the AIA's Guide to Energy Modeling, which is a very simple booklet to follow. Download the 2030 commitment by the numbers. There's some really great information in there that's very helpful. And I also put in something for a program called HEED, which is an incredibly simple, free program, cross-platform. If you're just starting out, certainly you can look at that. I just think that the more you do this, the more you understand where you can start making impact. And you want, again, everyone in the office to understand this. Don't just kind of hide it and have one guy do it. You want to make it very public and get everyone involved.
Yeah, I'll also just say that it's no fun for the one guy genius either to be in that office, just saying. Thank you so much.
Yeah. You don't want to be that guy. You want everyone to be part of the action.
For sure. All right, I think Eric, you're up for the last little bit, right?
Yeah, so I'll join you here for a bit. So we just wanted to, probably a question on people's minds as well. What tools should I use if I want to dive into this? We may not satisfy you with our answers here, but we want to give you a quick tour of the kind of tools that are out there. Starting with the ones that we don't necessarily recommend, the kind of detailed energy modeling tools. These are the ones that are good for early design analysis if you kind of climb the learning curve a little bit. But these are also the ones you would use for lead calculations or code compliance, utility incentives. And you see some of the names of those there on the right side. I think what we're more interested in this forum are the ones with early design focus. And we'll be talking about some of these in the upcoming October session too, where we'll dive further, but just kind of a quick tour here. So these first two, C-Scale and Forma, are actually not directly building energy tools, but they're focused on embodied carbon and life cycle carbon calculations. And the operational energy is kind of benchmark database based. So you wouldn't necessarily be creating two 3D models and comparing their energy use with these tools, but you can complement these with the other tools. So then the bottom four, Climate Studio, HEED, Insight, and Sapphira, these are energy tools. I'll kind of point out two things here. One is the input. So Climate Studio uses Rhino for 3D input. HEED uses its own standalone interface. It's a very simple drawing tool. Insight uses Revit for 3D modeling, and then Sapphira has plugins for both SketchUp and Revit. So, that's an important dimension here based on the design tools or the modeling tools that you're familiar with. That may lead you to choose one or the other of these energy tools. The second thing I'll point out is that they do other functions like daylight calculations, which, are very important, early design. And they may do comfort calculations. They may do PV calcs, so you can get some rough estimates of the energy production of a PV system, and maybe even natural ventilation. So it's useful to know that they have these other capabilities. And then point out that this is an evolving landscape. So there are tools that were available a year or so ago that now are maybe no longer available. Cove tool may be one that some of you have heard of that's not really an actively developed tool. Insight has changed. So if you knew Insight a couple of years ago, now it's different. So you want to check that out. But it's changing.
I would add just real quick, if I could add something.
Sure.
Some of the CAD programs have built-in energy modeling as well. So things like ArchiCAD and many others have it. And I'd also say, just for, I'm an older person here. We used to do it by hand, and then we used to use spreadsheets. And now with BIM, this is so simple. So like literally no excuse for not doing this.
Right. Thanks, Nate. Yeah, I should have pointed out this isn't a comprehensive list here. There are others out there. Right. So just a quick tour. So Sapphira is one example. You do your 3D model in SketchUp or Revit. It's a plugin. It does energy calcs with Energy Plus simulation engine and daylighting with Radiance simulation engine. You can vary envelope component performance, space usage like lighting power, plug load power. You could add shading, change HVAC system types. You could add a PV system. And then it gives you lots of very sort of useful, interesting reports. There's an annual license fee. And I won't go into all the details here, but just kind of a quick tour here. So this is the SketchUp plugin. So you create a 3D model. It's probably most useful if you're just kind of creating your energy model, sort of a simple energy model from scratch, rather than trying to translate your design model into an energy model. But there are workflows that allow you to do that. And then you can, vary parameters like wall insulation, floor insulation, solar heat gain coefficient, and so on. And then see quick results, like what's the impact on EUI, what's the breakdown by end use, what are the sources of the heating and cooling loads. So some pretty useful information. The other thing the plugin can do is daylight calcs. So you can model your windows, shading. It'll use radiance to calculate a number of different daylighting metrics that you might be interested in. Does that pretty quickly. So that's just a super quick tour of SketchUp. If you create a model in this program in the plugin, you could then open it in a web app, which would then give you more capabilities and allow you to do more detailed modeling. And I don't know, I should probably invite Jack to to speak to this slide. C-Scale's the other one we wanted to just talk to. Do you want to give a real quick rundown, Jack? If that's...
Yeah, happy to. In many ways, we built C-Scale to be complementary with energy modeling tools, where things like, building geometry, window to wall ratio, we'll look at the emissions associated with those materials, but it really is, as it says here, using sort of declared EUIs. So there might be a design that you're working on and you want to understand the carbon implications of moving from an EUI of 42 to 24 of the addition of solar, of the when we think only in terms of energy use, sometimes we miss opportunities around fuel switching. The effects of fuel switching, obviously, as Eric mentioned earlier, will depend on the electrical grid where the building is located and the sort of patterns on that grid. But it sometimes has very large carbon implications to move from something that's mixed fuel to, we'll say, all electric. So that's really the extent here. And the other thing I think that we really look at with C-Scale is putting those the use of the operational emissions in context to understand trade-offs, because we recognize or have recognized in practice, us and many others, that there's only so much to go around. And when you are figuring out how to allocate resources for sustainability strategies, does it make more sense to target the next level of energy efficiency or to do something like specify lower carbon concrete? So putting it all in one big decision-making space is really helpful, we think, for sort of like giving context to these decisions. But really, again, C-Scale's kind of carbon modeling tool meant to be complementary with some of the early phase design energy modeling tools that Eric called out. So you can input an EUI, but you can't figure out why the EUI is that way within C-Scale, if that makes sense.
Right, great. And it's in my experience, a very simple and interesting tool to use. So I think, Ron, I'm passing it back to you then.
Yeah, thank you, all of you. So this is essentially the last bit of our entire event, really, which is hopefully the best part. Some discussion questions, and then we're going to open up to some Q&A in between to the audience as well. So I'll open it up with question one, which is, what challenges have you faced when scaling up energy modeling across a firm? Really hoping that we can hear a little bit of the process that you undertook to get energy modeling really ingrained into your design process firm-wide. Jessica, perhaps you could start us off?
Sure, yeah. For context, right now I'm working for a firm that there are 10 of us, so we are very small, And it was really important to us that everybody had the kind of like knowledge and vocabulary to be able to, maybe if they're not doing energy modeling themselves, have the conversations with our consultants that are doing energy modeling. And I think this was probably one of the larger challenges that we faced when we were trying to make sure that every project was doing energy modeling. And part of that is that as we saw in these slides, there's a lot of terminology that can come with energy modeling. And so we found it really important to narrow down what exactly we were looking for from our energy model. Like, not just that we were going to do energy modeling in quotes, but like we needed to do energy modeling so we could like find the EUI and report to the AIA DDX, or like we needed to do energy modeling so that we could evaluate what percentage of windows we should use on a project, or so that we could reduce the operational cost by this much, or whatever the goal for the project was, rather than just like blanket, we're doing energy modeling. And to do that, we had to, as a team, kind of train up and educate ourselves and each other on what the different types of energy modeling softwares were out there. And so we did a lot of bringing in consultants who were trained and specialized in energy modeling to tell us about what they do, like you guys are doing here, and hearing about the different types of models that exist, understanding the difference between like performance and prescriptive models for compliance, and what the different softwares could give us in terms of informing our design decisions, because some are finer grained than others. So some could actually help us with some of the like larger design decisions, and some were more to help us just understand like the cost implications or the compliance implications. And I think that kind of general building up of our knowledge of the building performance literacy and like vocabulary was really important. And working with our consultants and working with peers who had done this before was really key in us kind of like all coming together and being able to have these conversations with clients moving forward.
Thank you, Jess. Yeah, and I do want to mention those because Jessica just mentioned how there's different levels of detail to the different modeling tools, right? It's the same with the lists that we had up earlier. Those detailed models like DOE2, EQuest, IESVE, those are the kind of models that you ultimately need to submit to Z and Co at Hawaii Energy, because you need a detailed model that they can review to get you those incentives, right? Because they need to make sure that everything you're saying actually checks out. The other really like early stage modeling softwares, those won't quite get you to code compliance firstly, because DPP won't accept that, neither will any of the other county agencies. LEED won't accept that either, and also sad face, Hawaii Energy also won't accept that. So there are some decisions that you need to make when you're going through your construction process on like what level of detail you're going to plan for. That being said, I'm gonna punt it over to Nate, perhaps. Hopefully you can hear me. If not,
Yeah, I'm hearing you
Okay.
just this 1 second here, so I'll go.
Hey.
Being a part of the 2030 commitment from the very beginning, I was on the committee when we, detailed the DDX and when we detailed a lot of the stuff. So and I was the small firm in that group so that I could give that perspective. And we just kind of ate it up. We started doing the energy modeling, and everyone in the office is expected to understand what we're doing. And we're a special case. Our firm is so specialized in this that when people call, they know what they're going to get. When people apply to our office to work, they know what they're getting into. So we try and hire people that really are into this. So I know that's not typical of every firm. So I think what you have to be ready for is that a lot of people don't understand this yet. So you have to figure out how to kind of slowly bring people up to speed on it. But like I've said before, it's important to get everyone on board as part of the firm culture. That's the reason that we have a sustainability action plan as part of the 2030 commitment. It's not just about producing the numbers and producing a building, it's getting everyone fired up about it. And that's kind of contagious. You want to market that. And I'll tell you what, I had to talk with everyone on the call here the other day, and I was thinking about it. I was told that not that many people in Hawaii are doing energy modeling. And I would say you should, as architects, you guys should get on the ball because you're going to be the ones at the forefront of this. You're going to get all the work. So get going on it quick and beat your competition, and you'll end up with lots of work. I'm guarantee it. We're busy right now, and a lot of people aren't, and it's because we specialize in this. And it's taken a long time for people to get on the ball. So again, get going on it quick, and you will reap the benefits and beat out your competition, and you will own Hawaii's sustainability work. That's my opinion.
Thank you, Nate. Lastly, perhaps we could hear a little bit from Jack. You worked at EHDD, which is a little bit of a larger firm. Perhaps you could tell us a little bit about how it worked there.
Yeah, totally. And just to, I'll say, like, extemporize on Nate's comment a little bit, this chance to, like, yeah, have this differentiator in practice and to get these incentives to pay for it. It sounds like a pretty good deal to me. No, like at EHDD, 80 to 100% firm, like depending on the way the wind blew. One of the biggest, I think, things that was just always like the way that this happened, and I think I try to highlight this too when I talked about how you learn about energy modeling, is so much of this work happens between people. These things seem highly technical, and they are, but really, like, the thing that makes it happen is the check-ins with the project teams, sitting down with them and working through the problem, asking the right questions to the consultants. All the things that make good design happen also make performance modeling happen. And to understand, I think, most essentially the relationship between those two things, so that when you do, many firms will say have a design review or a detail review, right? A constructability review. Layer in things like the AIA's framework for design excellence when you do these sort of internal reviews, or when you do shreds, just ask the question every time, right? Internally, well, how might this affect energy performance? And by doing this, by really trying to fold it into the design process, you're able to sort of build the muscles as a firm, and from those muscles, build structures, and from those structures, build the practices that allow you to win the work, right? To put this forward. And I think the other thing that both Jessica and Nate mentioned is that there will be moments where, like, you just feel the spark. You're like, oh man, I think we just won that project because we were able to, demonstrate that we were able to bring this value to the client. Or when you really have a win and maybe the client's, not asking like for a net zero building, but you're able to do it anyway, right under their nose, like give them a better building, right? Like these feel really good, these wins. So finding ways to celebrate those, participate in awards programs, et cetera. But really just focus on, building culture and practices amongst the people at the firm. I really don't think this can be underestimated.
Thank you, Jack. So we've got a few more questions, but I want to open it up to the audience to see if you guys have any questions they want to ask our esteemed panelists. So, Eric, if you want to monitor the chat for any questions there, and I'll open it up to our in-person audience here.
Yeah, we do have a question online from Ignacio. Shall I read that for you?
Yeah, go ahead.
Right. So he notes that construction is not as exact as modeling, and quality control can impact building performance greatly. Have you compared the energy model results with actual testing and consumption data after construction? What range of discrepancy would you find reasonable? I guess, do any of our panelists have experience with that?
Well, I'll go just because I heard that question, so I'll just jump right in. We've done a number of passive houses now, and we're starting to get data back on that. And the metric that we've been using is the energy bill, and it's been zero or a penny or negative. We're getting credits, so it is working out pretty close to how we figured. We told the owner, don't change a thing for a year. Let's get a good solid baseline in. Don't change a thing. We've made it through the year. And what we did do is we asked the solar provider to check his energy supply because we were seeing some discrepancies year over year, month to month on the energy production. And we think the energy provider is not accurate, like wildly off target.
Yeah, I mean, this is a big question, but the context of net zero energy buildings really puts a spotlight on energy models and whether they're correct. And I think we're getting better and better at creating models that can come close to
I'm
actual
sorry.
consumption.
Yeah.
But
I
Jack,
can
you have a-
maybe jump in there with like just on that point exactly. An EHCD project that happened before my time there was the Exploratorium, which is a small museum in San Francisco on a pier, lots of cool science exhibits. Modeled as a net zero project in 2013, right? But there's all these like science exhibits, some of which are super energy intensive and equipment breaks sometimes, and people aren't in the building exactly when you expect them to be. And it was not until 2023, 10 years later, where the Exploratorium was finally able to consistently produce in a year as much energy as it consumed. You know, net zero is a living goal. It's something negotiated in every day of the building's operation. And I think like what you're saying, Ignacio, is exactly correct, right? There is this gap. And this is why like handoffs, just like architects, interact with building owners and facilities people, like is really important. The other thing I'll note, that maybe is a great follow-up webinar to this, just to put it in the AIA Honolulu's quiver, would be to talk about commissioning, which is the process where as the building systems are coming online, where they're sort of like peer reviewed to make sure everything is dialed in exactly right. There's envelope commissioning to make sure the envelope is constructed quite right to deal with exactly some of the questions that you're raising, Ignacio.
I have to say I love the commissioning angle there. Some of my firms where I worked, we had an in-house commissioning team, and they were essentially known as the superstars of any high-performance builds that we did. Because more often than not, we would go after something that is supposed to be net zero carbon or net zero energy. And when you're in that first 6 months of the recording period, things are just not adding up at all. And that's when our superstars would go out there and they'd be like, oh yeah, well, some mixing valve was not working entirely right at all. And it helps us, it often helped us get right to the modeled results that we had gotten, or at least very close. I will also say though that sometimes models do have limitations. So there are also times when models are a little bit off of what the real time analysis ends up being kind of. Yeah, go ahead.
Well, so, talking about commissioning, what would be a reasonable period, after, post occupancy? Is there a period that would be sufficient to determine the performance, not only the system, but also maybe whatever else?
So let me just repeat that question. The question is essentially, what's a reasonable period of time after essentially post occupancy to maintain for commissioning to make sure that everything's going well? Yeah, good question. Looking at
Better jump in, Jessica. That's put you on the spot there.
You can take it.
Just to say, I mean, this is like the dumbest answer, but a year is pretty good. Like you see all the seasons, the sun goes around one time. You get the winter, you get the summer. And that's often what like the standards use as well, is 1 year of data post occupancy.
Yeah, that's what we've used. And like to Ron's point, it does help you find if something's not working. We had a project where like the solar just didn't get plugged in, and so we weren't getting any feedback. And halfway through the summer, we were like, this doesn't seem right at all. These utility bills don't make any sense. And it tells you right away. So that's the other thing energy modeling can do, is tell you what to expect when you start getting utility bills.
The reason I ask is that, you mentioned 1 year, but 1 year is a period of warranty for any construction contract. So, after that, I mean, you need to know how well the building is performing over time, and whether your projections for savings or whether it's monetary or energy savings or whatever, how it's performing. That's what I would.
Yeah, so essentially because warranties usually last for a year, what about the time after that? Yeah, it's a good point. I will say, I have. This is one of those times where I should probably not say too much, because commissioning was not my scope of work ever. But I just know from the principals that I usually work with, a year typically was close to the max that we could get scope for, just due to project costs often. So I'll just add that from the engineering perspective, at least from consultants, we had to often kind of fight a little bit to make sure that we could at least get scope for 1 year of commissioning for our high performance buildings. I don't even know how much they push for the other types of buildings. So there is that angle as well of like how much you can get scoping for.
Well, you know, years ago, the state was if you had commissioning for any units, it was being designed. About over 20 years ago, I did the campus center. Big trim expanded. And along the way, it got lost because, you know, as far as the guidelines, my understanding was you do a lot of work before starting a commission. Starts early with site, and then you go on and what I was expecting was a performance period, maybe 10, 15 years or whatever, you know, to be a life cycle, life cycle of the building, say 30 years, or something. So that's what I was expecting, but along the way, the proposal got lost. There's no final execution.
Sounds familiar. All right. Yeah, Sophia, you have a question. I'm gonna pass the mic to you.
Oh, I don't have a question. I just wanted to actually interject and say, not only do we do energy modeling rebates, but we actually have a commissioning rebate as well. Yeah, so it's actually 20 cents per square foot, up to $30,000 or half of the project cost. So, yeah, whichever one's less.
Fantastic. Hawaii Energy trying to pay more of your. Perhaps for the next one, we can put a commissioning slide in there just to let people know. That's awesome, though. I didn't know about that one either. All right. We are essentially at time. So we did have a couple more questions, but you know, we have covered a lot of the questions already. So I just want to take a moment to thank our panelists and Eric as well for their time. Some of our panelists are all the way from the East Coast, so it is essentially past midnight now. So thank you so much for your dedication, for being here. We appreciate it very, very much.
Yeah, thanks for
Thank
having me.
y'all.
And I just want to shout out that we are going to continue this series. So we'll have the deeper overview on modeling tools on October 29th. And we're going to work on that hands-on one too. And lastly, COPE has put up this QR code with a survey on it. So if you guys have the time, please take the survey. It's just let COPE know about kind of things you'd like to see from them. So thank you once again, everybody, and Eric too. And hope you all have a great night.